Hi, Integrated Math 1. Welcome to Module 2, Topic 2, Lesson 4. We're doing Day 2, the second half, Part B, however you want to think of it, of this lovely lesson. We did want to break it up because there's a lot going on here. Of course, we have been talking about compound inequalities. And so if you recall, a compound inequality is an inequality that is formed by you having two inequalities, two simple inequalities, with the word or, which we refer to as a union, or with the word and, which we refer to as an intersection. And we're going to play around more with that today about why we call that a union, or is a union, and is an intersection. So we're on activity 4.3 on page M2-141 in your workbook. So again, compound inequality is two inequalities, and in the middle we have the word or maybe we have the word and. If you recall, when we use the word and, we also had the option of writing it as a compact inequality that we could squish it down all into one little guy. Didn't have that option with or, but that's okay. So I want to get a little more detailed here. So when we find the solution of a compound inequality in this compact form, A is less than X is less than B, we know that this is one of our ands, right? This is the and form of our compound inequality. So where A and B are any real numbers, and it's the part or parts of a solution that satisfy both inequalities. So whatever you plug in for X has to satisfy that it's bigger than A and remember, and smaller than B. When this happens, when we have this compact inequality, when we're using a compound inequality with the word and, with that intersection, this type of compound inequality is referred to as a conjunction. It's a conjunction, right? It's an intersection. It's where it all meets up. If, however, the solution of a compound inequality, because we did a little bit of this last time, is in the form of X is less than A or, now we have the word or, it's a union now, it's the word or, X is greater than B, where A and B are any real numbers, and of course X is the part or parts of the solution that satisfy either inequality. So either X is less than A or X could be bigger than B. When this happens, we call this type of inequality, compound inequality, a disjunction, okay? So when we're using the word or, this becomes a disjunction. If we're using the word and, it's a conjunction, all right? Good things to know, because I want you to go back to the previous activity 4.2, and we did a whole bunch of activities there on 4.2. We did a whole bunch of problems on activity 4.2 on our last lesson, and we came up with 3 different solutions because we had 3 different problems, 3 different scenarios, and these were our solutions. I went ahead and wrote them here to make it a little easier with flipping back and forth. And what I would like you to do is I'd like you to classify each of these solutions as a conjunction or disjunction. Go ahead, hit pause, write down whether it's a conjunction or disjunction, and then hit play when you're ready to check your work. So for this first one, W is less than or equal to 32, or W is greater than or equal to 212. I see the word or, that tells me right away, this bad boy is a disjunction. Yes, it is. Over here, I have 1 is less than or equal to D is less than or equal to 5. Ooh, it's a compact one. This is an and guy, isn't it? So that means it's a conjunction. And of course, we have a similar issue here. 24 is less than or equal to M is less than or equal to 32. It's a compact inequality. It definitely is an and situation. So this one will also be a conjunction. Conjunction, junction, what's your function? Oh, we've done functions and conjunctions, and you thought it was just for English class. Ha ha! So let's take a look at 2 examples for representing the solution of a compound inequality on a number line. We've already been playing around a little bit with these, putting them on number lines, and you've already been getting a feel for it, but we're going to start messing with your head a little bit today, so watch out for that. So the compound inequality shown involves and, right? You could write it as -3 is less than X is less than or equal to 1, or if you split it up, it's often a lot easier to graph when you split it up. We can see we have X is less than or equal to 1 and X is greater than -3. So let's do each of these above the number line. Here you can see X is less than or equal to 1. So here's my 1, closed circle, since it's equal to, And because it's less than, we're going to go left down the number line. Then if we do the other inequality, x is greater than or greater than negative 3, there's no equal to, so it's an open circle at negative 3, and of course it's greater than, so it moves to the right. Now, when we say and, that means both of them must be true. Our solution is the region that satisfies both inequalities. This is why we refer to it as a conjunction. This is why earlier we were referring to it as an intersection. The solution is the overlapping parts, or the intersection. So on my number line, I'm going to do open circle at negative 3, because that's what we had here. I'll do a closed circle at 1, because that's what we had there. And we're just going to shade in the overlapping, so the in between. So graphically, the solution is the overlapping or the intersection of the two separate inequalities. It says and. If it says and, they both have to be true, right? And this is that. So where it's true for both of them is where it overlaps. Yay. So whenever we see and, we're always looking for that overlapping, and all we want is the overlap. But if I'm looking at or, our situation changes, okay? The compound inequality shown involves or. It's a disjunction, right? So we have x is less than negative 2 or x is greater than 1. So again, we'll put each one above the number line to see what happens. So if I do x is less than negative 2, open, because there's no squashed equal sign. Less than means we move to the left. Then we'll do x is greater than 1, so open circle at 1 because there's no squashed equal sign. And of course, greater than means we go to the right because that's how things get bigger on a number line. Now take a look. The solution is the region that satisfies either one. Because it's or, that means I want all of this guy and all of that guy. It can be either one of them, so they both are possible solutions. So graphically, the solution is what we call the union of all the regions, okay? It's the union or all the regions of the two separate inequalities. So when we use the word or, that means we got to bring everybody together because it could be either one of them, all right? So with this in mind, it matters when you change the word. It matters whether you're doing and or. If it says and, it's just the parts that overlap. It's the intersection. If it says or, then it's a union. We need all of it. Everything from both of them. Everything from both inequalities gets chucked into the mix. So with this in mind, let's see what happens if we change the wording, because it changes things. So if the compound inequality in the first worked example originally was an and, right? X is less than or equal to 1 and x is greater than negative 3. If we change that, and this is critical, if we change that to or, so x is less than or equal to 1 or x is greater than negative 3, how would our solution set change? See if you can graph it on a number line. Figure out how that's going to change and write a little explanation for that. Go ahead and hit pause, do this to work out the graph and to jot down your thoughts, and then hit play when you're ready to check your work. All right, I'm going to graph the first one. And again, remember how we did it up above so we could figure out where intersections are or figure out what the union was, all that good stuff. So we'll graph up above. So x is less than or equal to negative 1. So we'll do that's a positive one. So we'll do a closed circle at 1. And it's less than, so we got to go to the left. There it is. Or x is greater than negative 3, so we'll do an open circle on negative 3 this time. And it's greater than, so we'll go to the right. Now, it's using the word or. Or means it's a union. Or means it's all the regions from both inequalities. So if I use all of this guy and all of that guy, and I kind of squish them down on here, I have everything. I have everything. So when I changed it to an or, the solution set actually became the set of all real numbers because it's the union of the individual inequalities, right? You have to use everything from both inequalities. If I use everything from both inequalities, I'm literally using the entire number line. That's the thing. So let's take a look what happens if we change or, shall we? So let's consider that second work example. If the compound inequality in the second worked example, x is less than -2 or x is greater than 1, if we change that, if it was changed to the conjunction x is less than -2 and, I'm going to circle that, that's so important, and x is greater than 1, how would the solution set change? Again, play with the graph a little bit and then explain what happened. Go ahead and hit pause to work that out and then hit play when you're ready to check your work. So again, up above, I'm going to graph them individually. So x is less than -2. So we'll put an open circle on -2. Less than means we go to the left. X is greater than 1, so open circle at 1, and greater than means we're going to go to the right. Now it says and, doesn't it? Guys, remember when it says and, it's an intersection. It's an overlap. There's no overlap. Nothing overlaps here. There's no overlap at all. So what does this tell us if nothing overlaps, but it says and? Well, that means there's no solution because the graphs of these inequalities don't intersect. They don't. There's no overlap. I can't have an and if there's no overlap. That's not how this works. Fine. We'll go on then. So here's what I would like you to do. I've got a whole bunch of problems for you, a whole bunch of problems. I know. 99 problems, and math is a whole bunch of them. I've got a whole bunch of problems here for you on page 142 and 143. So for number 3, you've got A, B, C, D, E, F, and G. You got a good chunk of the alphabet here. I would like you, for each of these, A through G, and I couldn't fit them all on one page. You have them all on one page on your paper, but I can't fit them all on one slide here. So what I would like you to do for each of these, A through G, represent the solution set to each compound inequality on the number line. So start by up above, right? Graph each one, and then write the final solution that represents the graph. So pay attention to whether it's or and. Or means it's a union of both of the inequalities. You got to use everything from both of them. And means it's only the part that overlaps that intersects. So go ahead, hit pause, work your way A through G, and then hit play when you're ready to check your work. All right, so I'm going to graph them up above just to, maybe I won't, maybe I'll do them right on the graph. So x is less than 2. So here's 2, put an open circle on 2. It's less than 2, woo, so go to the left. X is greater than 3, so open circle on 3. Greater than means I'm going to the right. Oh, and it's or, so it includes both of these. So I guess it was already written okay just the way it was. Fair enough. Let's take a look at B. This is an and situation, isn't it? When it's compact like that, that's an and situation. And oftentimes, we mentioned this in the last lesson, I find it easier to graph them if I split them up. I'm like, okay, well, I can see here that x is less than or equal to -1, right? Alligator eats the bigger one. But then I have this other inequality that says x is greater than or equal to -1. And because it was compact, we know this is an and situation. So I find it just helps if I make a few notes here, makes it a little easier for me to work these out. So let's do this. X is less than or equal to -1. So that means close circle at -1. I'm doing it up above because I want to look for that intersection. It does say and. So close circle at -1, less than means I'm going to the left. Yay. And x is greater than or equal to -1. So again, a closed circle at -1. Greater than means I'm going to the right. And means intersection. It means where do they overlap? Take a close look at these. They only overlap at one point. They only overlap at -1, right? All this stuff to the right does not overlap all this stuff to the left. So the only solution was x equals -1. Well, there you go. Fine. How'd you do on this one? X is less than 0 or X is less than 2. So again, I'll do it up above just so I can see a little better. So X is less than 0, open circle above 0. Less than means I'm going to go to the left. X is less than 2, so open circle at 2. Less than means I'm going to go to the left. Oh, they both went left. This says or. Remember that or means you've got to include everybody, but I'm going to squish them down, bring them down here and compact it down. So I'm just going to go from 2 to the left, which means I can actually simplify this solution as X is less than 2. Because this guy, this X is less than 0, got kind of caught up in the X is less than 2 excitement. I did. Let's look at D. X is greater than 1. All right, open circle at 1. X is less than -2. Oh, sorry, greater than 1, so I got to go to the right. My bad. Sorry. X is less than -2, so open circle at -2. I'm going to go to the left. Oh, wait, this says and. That has an and on it, right? That's an and. And means they have to overlap. They don't overlap. There's no solution. That's so sad. Fine, be that way. Let's do the next one then. So X is less than 3. All right, so open circle at 3, and we're going to go to the left because it's less than. X is greater than 2. Fine. Open circle at 2, and we're going to go to the right because it does say greater than. Ooh, intersection, overlap, intersect. We just want the overlap, right? So if we just want the overlap, we're just going to go from 2 to 3 and everything in between. So that means we can write this as a compact inequality. So I can say that 2 is less than X is less than 3. Nice, nice. I like putting it on the number line. It makes it easier to write these compact inequalities, right? They kind of squish down nice. What about F? X is less than 2, so open circle above 2. Less than means we're going to go to the left. X is less than -1, so we're putting an open circle above -1. And less than means we're going to go to the left. Now remember, and, we have the word and here. And means intersection. And means overlap. I'm only overlapping from -1 down. So that's what I'm going to put on my graph for my final prettiness. So -1 down. So that means I could rewrite the solution as X is less than -1. Fair enough. Last but never least, G. X is greater than 1, so fine. We will put an open circle at -1. Sorry, X is greater than -1. Open circle at -1, and greater than means we will go to the right. Yay. X is less than 0, so open circle at 0. Less than means we go to the left. Yay. And this guy has the word or sitting in the middle. Or means everything, everything. You're going to take all of this, and it doesn't matter that it overlaps. You're taking it all. But because they overlap, that means it's a union. It takes everything. That means it's everything. It's all real numbers. It's everything now. Fine. Be that way. So some of those got a little crazy and a little confusing. Feel free to rewind and go back and rewatch if you need to. It's one of the joys of YouTube, right? It's not a bad thing. If you're ready to go on, though, we're moving on to activity 4.4, where we're going to solve our inequalities that are in compact form. So to solve a conjunction written in compact form, you got to isolate the variable between the two inequality signs. So remember our conjunctions. That's when we use the word and. We could write them in compact form. So our variable was in the middle. That means that if that variable in the middle is not alone, you got to get it alone. So we'll do that. And then, of course, graph the resulting statement. To solve a disjunction, so disjunctions use the word or, that was the union. So simply solve each, it just has two inequalities with the word or in the middle. Fine, solve the two inequalities, keeping that word or in between them, and then just graph the resulting statement, and you'll be fine. Yeah. I think you can manage this. But before I set you loose, I want to show you an example. Make sure you're okay. So here I have a compound inequality. -3 is less than or equal to 2x plus 7 is less than 11. So you can see I have two inequalities here. So it is definitely a compound inequality. It's definitely a conjunction. It has the word and, right? Because when you can write them compact, that means they have the word and. So here's a cool trick. Up to this point, we've been separating our inequalities, our compound conjunction inequalities to help us graph them better. But you know you don't have to separate these guys in order to solve them. You know the rule, right? If what you do to one side, you got to do to the other. That's okay. It just means you have three sides now. Oh, sorry, that didn't work out well. It just means you have three sides that you need to work with. So what you do to one, you got to do to all. We got to be fair. So in order to get rid of this plus 7, we can subtract 7. But notice how we subtracted 7 in the middle, we subtracted 7 on the left, and we subtracted 7 on the right. You have to do it to all three parts. Everybody gets it. And of course, -3 minus 7 is a -10. We did this so that it would cancel out. That's how we get rid of a plus 7. And 11 minus 7 is 4. That means, once again, if I want to get the x all alone, we do have to divide by 2. But notice how we divided by 2 in the middle, on the left, and on the right. So to get x alone, we divided by 2. We just had to do it to all three parts. And of course, -10 divided by 2 is -5. 2x divided by 2, oh, they cancel out. That's why we did it. So we just have an x. And 4 divided by 2 is 2. And now this is easy to graph, right? You can see we have a closed circle at 5. We have an open circle at 2. And because it's a conjunction, we shade in between. Yay. So can you just make some notes here? This is more to help you. This isn't so much like showing off how smart you are. Make some notes here. It's going to help you out a little bit on number 1. How is solving a compound inequality in compact form, what we just did on that last example, how is it similar to solving a simple inequality? And how is it different? Go ahead and hit pause to jot down your thoughts and then hit play when you're ready to check your work. So the first thing I noticed is that we're actually using the same rules, right? We undid addition with subtraction. We undid multiplication with division. So in that way, it's similar, right? When solving a compound inequality in compact form, you complete the same algebra steps as you would if you were solving a simple inequality, right? We're doing the same thing. We're getting x alone. We're using inverse operations. That has not changed at all. The difference are that the algebra steps must be applied to all three portions of the inequality. The other thing to watch out for is this, and I'm going to use a different color just so you can really see it better. If you are multiplying or dividing by a negative, remember how when we multiplied or divide both sides by a negative, how it reversed our inequality? You now have to reverse two inequality symbols. So if you multiply or divide all three portions by a negative, you have to reverse both inequalities, not just one of them. All right? So remember, that's our extra special bonus trick. So with this in mind, I would like you to go over to question number 2. There's a whole bunch of these. Again, I can only fit so much on my page, but there's a whole bunch of these. Number 2, there's A, B, C, D, E, and F. I would like you to do all of these. Solve it and graph it, okay? Make sure you show your work. Make sure you write your final solution, that you put it on the graph, all of that good stuff, okay? Just like that worked example that we did on the other page, just on the page next to it, 144, do the exact same thing with A, B, C, D, E, and F. So go ahead and hit pause, work them all out, do all your graphs, and then hit play when you're ready to check your work. So let us begin. Let us begin. I see the x. I want x to be alone. So fine, I'm going to add 6. But remember, you have to do it to all three pieces. No problem. Those cancel out. Easily fixed. 6 plus 6 is, of course, 12. Less than x is less than or equal to 15. Great. Well, that was easy. X is alone. Hooray. Now let's graph it. Open circle at 12. Hang on, I got it here. Open circle at 12, close circle at 15, and color in between. Yay. How'd you do on this one? Did you remember? There's a few tricks here. Did you remember them? Do you remember how to turn that negative into a positive? I bet you do. We've done this several times now. I keep torturing you guys with it. Remember, you can turn this negative into a positive. There's a few ways of doing it. An easy way is to multiply by a -1. But remember, you have to do that to all 3 portions. So do it to everybody. -2 times a -2 is a +2. Negative x times a negative x is a positive x. And 6 times a -1 is a -6. Now, do you remember? Do you remember? We are multiplying all 3 of these guys by a negative. That means both of these inequalities have to be reversed. So that means instead of less than, these just became greater than. To help me graph this, to make it a little easier on me graphing-wise, I'm going to flip the whole thing around because when we graph, we like to go least to greatest. So I'm going to do -6, which is less than x. You can see alligators eating the x, which is less than 2 because, again, you can see alligators eating the 2. So I'm just going to switch it all the way around, flip it all the way over to make it easier for me to graph it. And I'll show you my graph. Open circle at -6, open circle at 2, and we color in between. Color in. Ooh, 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 we're coloring. How'd you do with C? To start, I subtracted 1. Got to get that x alone, but you got to do it to all 3 sides. So there's death and destruction there. Grab my green pen. That makes a -5 less than or equal to -3x less than or equal to 11. You know what the next step is. You know what the next step is. You got to divide everybody by -3. Ooh, and this has a few effects. Like, yes, okay, those cancel out. That's why we did it. But this creates a few little things, right? Because since we divided all 3 by a negative, we've got to flip around our inequalities. So I'm going to flip those around. This makes for just a plain x in the middle. And negative divided by negative is a +5/3. Positive divided by a negative is a -11/3. I don't like the negative on the right. I want it on the left. So I'm going to swing everybody around. -11/3 is less than or equal to x is less than or equal to 5/3. For purposes of graphing, it might be a little easier to think of this as -9 2/3, like 3 goes into 11 9 times with 2 leftovers. For purposes of graphing, it might be easier to think of 5/3 as a 1 2/3, right? 3 goes into 5 ones with 2 leftovers. Just makes it easier to graph. So I will graph it. Pardon my mess. So closed circle at -11/3. That's not well done. That's not a 9. That should be a 3. Why don't you guys correct me when I make mistakes? Oh, because I can't hear you because it's a video. That should be a 3. Thanks. So closed circle at -11/3. Closed circle, you can see closed circle at 5/3. And of course, x is in between. So we color the in between. Good job, us. For part D, oh, this one has an or on it. No big deal, no big deal. We can manage ors. We can do ors, no big deal. We just need to solve them individually, right? So let's do that. So I'm going to subtract 7. So that's canceled out. So now I have 2x is less than 3. Or we got to do something similar on the other side, right? We got to do this guy too. So -7 minus 7 to get rid of that plus 7. So I now have -2x is greater than 3. But we're not done yet. We got to get those x's totally alone. So I'll divide both sides by 2. And because it's a positive, I don't have to worry about flipping around. inequalities because it's positive. So I just have x is less than, and I could leave it as 3/2, but I like to think of it as 1.5 or 1.5, a little easier for graphing. Or, wait, there's more. We got to divide both sides by a -2 here. Oh, whoa. We're dividing by a negative. We're dividing by a negative. That means I have to flip my inequality. So instead of greater than, this is going to be x is less than 3. What happens when I put that on a graph? Ooh, so when I put it on a graph, actually, I'm just going to do this. When I put it on a graph, what happens? Oh, sorry, I went too far off to the side over there. So I want to make sure I can see 1.5, and of course 3 is bigger than that. And there's other numbers in between, but I'm just going to do that to help me out for now. So x is less than 1.5, so open circle, and it goes to the left. X is less than 3, so open circle and goes to the left. Oh, and of course, or means union, or means we include everybody. So I include all of this. If I include all of this, that just means I'm starting at 3 and working my way down from there. Do you like my coloring? It's so pretty. There it is. That means, though, that I can rewrite my solution instead of writing all of this out. Oh, that should say 3, shouldn't it? Yes. So x is less than negative. Oh, no. Why don't you guys tell me when I make mistakes? Hang on. Miss Scott made a mistake. You didn't tell me. Hang on. I did make a little mistake here. Watch out for that. Sorry, my bad. So here we have negative, when I divided by -2, 3 divided by -2 is a -1.5. I hope you caught that when I did it earlier. If you did, good job. Even Miss Scott makes mistakes sometimes. That's why I like to erase things. So sorry, that changes my graph. So 1.5, open circle to the left, -1.5, open circle and to the left. And the union of which means we start at 1.5 and work our way down. So our solution is actually just x is less than 1.5. Sorry, I messed you up. My bad. I hope this makes it better. We're trying. Let's do this one. It's another or. Let's see if I can get this one right. Can I get this one right? I think I can. All right, so let's subtract 3 from both sides. So we get 1/2 x is greater than 1. Remember how to get rid of fractions? You know how to get rid of fractions. I can multiply by the reciprocal. So I'll multiply by 2. So those cancel out. And I have x is greater than 2. Hooray. Or, I have it on the side here. Remember how we get rid of that negative? You know how to get rid of it. We multiply by a -1. You know, we've done this a whole bunch of times now. We've done this so many times. But when you multiply by a negative, it flips your inequality. So negative times a negative is a positive x. Positive times a negative is a -3. Oh, dear. Oh, dear. Here we go. It's better. So x is greater than 2 or x is greater than -3. But this creates some issues. Let's see what happens. We know we want a -3 on there. We know we want a 2 on there. -3 is less than 2, so I need to be careful where I put these things. Open circle at 2. Greater than means we're going to the right. Open circle at -3. Greater than means we're going to the right. And of course, the or means we've got to include everybody. Oh, we have to include everybody. Well, if I include everybody, that brings me all the way up here to -3 and includes everybody down to the right or up to the right. Well, that means I don't really need this guy then, right? I don't really need the x is greater than 2. I just need x is greater than a -3. I kind of made that greater than 2 a little obsolete, didn't I? So sad. Last one. And of course, we've got some or going on here. Or. So fine, let's solve each of these individually. I'm going to subtract 1 from both sides, which gives me 6x is greater than 10. I will divide by 6 on both sides. I'm going to go ahead and simplify this, which gives me x is greater than, if I divide both of those by 2, sorry, my division sign went weird, my bad, then I get 5/3. Or we have this guy over here, x minus 4 is less than -5, so I'm going to add 4 to both sides. And I get x is less than -1. So, or x is less than -1. Once again, I'm going to put it on my number line. I can see I have a -1. 5/3, I'll just put 5/3 here, but I mean, that's actually 1 2/3, however you want to think of it, but I want to make sure I get it on my number line. Open circle at 5/3, greater than means I go to the right. Open circle at -1, less than means I go to the left. Oh, and or means it's a union, which means we got to include everybody to the party, people. Everybody's coming to the party. So that means I want both of these. I want both of these. I want this guy. I want this guy. Yeah, I want them both. So this is my final solution. I didn't have to throw one out, which is nice. I always feel bad when I throw one of these out. It feels wasteful, right? All that trouble and just threw it away. It's like it doesn't even matter. It's a little harsh. All right, guys. We had a few bumps along the way, but I think we got there and figured it out. Again, you're welcome to rewind this, rewatch it as much as you like. That's totally fine. You're including the problem I messed up on. You are welcome to rewatch that and laugh at me long and loud and hard for as long as you like. As always, if you got questions, let me know. Talk to me during class. Come see me during office hours. I'll help you out. I hope this is helpful. I hope this is useful and maybe even a little entertaining. And I'll see you soon. Bye.